Hi, it's Jocelyn. So this is Advent of Code Day 4. Let's see how it goes. So we have a bunch of numbers with commas, and then we have a grid of numbers, or a number of grid of numbers, one after the other. Okay, so giant squid. You're already almost 1.5 kilometers below the surface of the ocean, and we can't see any sunlight. What we can see, however, is a giant squid that has attached itself to the outside of the submarine, and it wants to play bingo. So numbers are chosen at random, and the chosen number is marked on all boards on which it appears. If all numbers in any row or column on the board are marked, that board wins. The submarine has a bingo system to help passengers pass the time. Okay, so the first line is the numbers that are called, and the remaining ones are the bingo boards. And okay, the score of the winning, so the board wins because it has at least one row or column of marked numbers, and the score of the winning board can be calculated by finding the sum of all the unmarked numbers and then multiplying that by the number that was just called when the board won. That is a weird score, but here we go. So I'm gonna start by just saying we have an iterator of lines. So the first line is the numbers that are called. So that's lines.next.unwrap. As you know, there's at least one line. We're going to split this on commas, and then we're going to, I guess we should parse them. And collect them, and this will be a vector of I32s, let's say. I32s are nice. And then the next number, the next line is, let's see. Next line is empty, and then there's the bingo board, which is, it looks like it's 5 by 5. Okay. So if there's a line that's next, then we're going to parse the bingo board. So I don't think a number can appear more than once in the bingo board, so I'm going to use a hash map here from the number to the position. So it's a bingo boards, we'll just call them boards, is a, this will just be a vector, and it's going to be a vector of hash map. So the board is a hash map, and that's a hash map from number to position. We have to make sure we have our coordinate system the same. But anyway, so we want to take 5 lines. Can we do that? Let's see. Creates an iterator that yields the first n elements or fewer. Okay, it takes it, so that means that we can't clone it. So I don't know. Yeah, so I don't know what the best way to do this is, but for y in 0 to 5, so that would be 0, 1, 2, 3, 4. We're going to take a line. So line is equal to lines.next.unwrap dot split. I'm going to split this on spaces. I don't like this format here. I'm just going to replace whenever there's more than one space, just with one space, using this little regex, just so that so that's easier to parse. And in addition, I want to make it so that if there's anything at the beginning of the line, I don't want those to be there. So now these are just, these bingo boards are just split by spaces. And this makes this easier so we don't have to use the regex library. So for, yeah, and we can enumerate these. And so we can say for x, because in enumerate the first item is the x is the coordinate and the second one is the number. Then we can say board.insert, and the key, let's do y and then x. That's generally the convention I use. X and y would also be fine. And then the number. Sorry, it's the other way around. So it would be number and then yx. Okay, so now I just want to make sure that this compiles. Oh, yeah. This needs to be in I32. And this needs to be, that was missing the in. Okay, so now for call in calls, and this is one thing I don't love about Rust. I wish I could always just say for additive code. I would just love to, yeah, for additive code in particular, I'd love to just like have all numbers be I32, because I don't want to think about whether they are negative or not. So here it's saying that we need to actually add something to board so that it knows the type. And so now we have a vector of hash maps as I promised. So now let's go through the calls. So for call in calls, and then we'll go through every board. Okay, so if the board contains the call, then we'll want to mark that as taken or as called. The way I'm going to actually do that is by adding yet another thing to our hash map that starts out as false, and we set it to true when it's called. So if let sum call is equal to board dot get mute call, then we'll say call dot, it's the third item, so call dot to equals true. After this, now we need to go through the boards and see if any of the boards are complete. So or actually we're already eating through boards, so we can do that here. So what does that look like? So it needs to be one row or one column. So this is, yeah, so we've optimized everything for actually, it's easier to use a different data structure here. We could do this, it just is looking annoying. Actually, yeah, this still matters. So I'm going to make like another called thing. And this is going to look really similar. This will just be a hash set of positions. Position is I32. So I guess we do need the in boards. so called, we'll say at yx. Oh yeah, I said I usually do yx. I really should not swap those. Sorry, called at I dot insert yx. Okay. Now, for board in boards dot iter, we'll just check if they're all called. So for y in 0 to 5, and then for x in 0 to 5, because you know they're both 0 to 5. Actually, yeah. So let's check the rows first. So row filled. Sorry, y. Oh yeah, sorry. So we're checking columns rather. So call filled. We'll say that it's true. And then for x in 0, 5, if darn it. I'll figure out why something's going on there. So then yx, then we'll just say call filled equals false, break, and then if call filled, then that's a bingo. I think that we made some kind of mistake here though. The other thing I dislike about Rust what is it complaining about here? So that's I32, and called wants, oh, darn it, I got that syntax wrong. It's easier just to do this. All right, so it's a tuple of I32s there. Oh my goodness. Okay, vector of hashes. This is the kind of stupid mistakes that you can expect. Okay, so fingers crossed. Okay, that looks promising. So now we need to process our bingo. So we're gonna find the ones that are not called. So I'm just gonna say let mute bingo equals false, and in this case, bingo equals true. Now we have to do the same thing for rows. So this is for columns, and rows are going to be pretty similar. We're just swapping x and y. Okay, so now if bingo, then so now we need to calculate the scores. So start by finding the sum of all the unmarked things on that board. Okay, so for y in 0, 5, for x in 0, 5, if called does not contain that that spot, then we need to include that score. Oh, actually, yes. So our data structures are again kind of annoying here, actually. We need the board here again. So the board is the boards at I, and that is a hash map of number to positions. something like that. Let's see if that works. Yeah, that looks good. So if call does not contain that that item, then we increment the score by that number, and at the end we're just going to return the score times the number that was just called, which we're calling call here. And let's see what we get. Hopefully this works. I32, I32. We're expecting an I64 here. That's fine. Contains any other minor typos? That'll be the death of me, I swear. Can never keep track of when numbers specifically are references or not during iteration. Okay, so we have a number. Let's see if it's the right number. It is. Okay. Going on to part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You're not sure how many bingo cards, bingo boards giant squid could play at once, so rather than waste time counting its arms, we're trying to figure out which board will win last and choose that one. That way it will win regardless. So this actually is going to be quite similar to the first one, but I'm still going to just copy and paste that just for time. Okay, so once something has once there's a bingo, what we're going to do then is check to see if it's the last one. So if boards dot length is 1, then we're going to do the same thing because it's the last one. But otherwise, we're going to remove it. So boards dot remove at I, and we also have like the called data structure, which is done like each index of called corresponds to the same index of boards, and right, because we're shadowing that. Darn it. We actually might run into, yeah, that's fine. Because we could be removing multiples, so I is to remove dot push I, and then we're going to go through those. So for I in I is to remove, yeah, actually, so if we do this in reverse, then the i's are decrementing, and we don't need to worry about recalculating the i's for the future ones. Otherwise, be careful. Then here we do call dot remove I and boards dot remove I. See if that works. Looks promising. I probably should get part B running then. And we have a number. And see if that works. We got it. Okay, so thank you for watching, and good night.